Imagine, if you will, the golden smidge from the Harry Potter universe.
Oh, yeah.
You know the one, right? That tiny, incredibly fast hovering golden sphere with the little wings that zips around the Quidditch pitch.
Seemingly with a mind of its own.
Exactly. Hold
Wow.
that specific image in your head. But now imagine if that magical little object had the cognitive processing power of ChatGPT, the conversational voice of Siri, and this is key, the sleek mass market form factor of Apple AirPods.
It is, well, it's a pretty wild visual, but honestly, it perfectly encapsulates the device we are looking at today.
Yeah.
We are exploring a piece of hardware called the Quicknitch, which is also going to be heavily marketed as Jinling Su in the Chinese market.
Right.
It is a palm-size, 32-gram autonomous flying AI companion, and the entire philosophy behind this device is to break artificial intelligence out of that glowing glass rectangle in your pocket and, bring it out into your actual physical space.
And to figure out how a company is actually pulling this off, we have an incredible stack of sources for this deep dive.
Oh, yeah. It is a mountain of data.
We are looking at deeply technical embedded firmware code, schematics for the internal boards.
Cloud architecture blueprints.
Yes, cloud architecture blueprints, mass production playbooks straight from the factory floor, and even some pretty intense geopolitical regulatory risk assessments.
It is a massive amount of technical data, but our mission today is to synthesize all of it for you.
That's why we're here.
We are going to explore how the convergence of microrobotics, edge AI, and large language models is creating an entirely new category of technology, something known as ambient computing.
Ambient computing.
Yeah, and we are going to unpack the massive technical, physical, and regulatory hurdles of building a flying AI companion that literally lives in your house.
You are going to learn exactly what it takes to pack a supercomputer's worth of intelligence into a device that is physically lighter than a standard AA battery.
It's mind-boggling.
And we'll look at why this just might be the biggest shift in personal consumer tech since the launch of the smartphone. So let's jump right into the vision and the form factor. What the design schematics are calling the minimum viable drone.
The MVD.
Because the core problem the Quicknitch is trying to solve is the inherent friction of modern AI.
Right. Think about how you interact with AI right now. The models are incredibly powerful, but the interaction is entirely physically passive.
You have to go to it.
Exactly.
Yeah.
If you want to use it, you have to stop whatever you are doing in the real world, look down, tap a screen, type a prompt.
Or maybe put a device in your ear and press a button.
Right. It fundamentally takes you out of your environment. The Quicknitch is designed to act as a floating second brain. It is meant to provide hands-free, eyes-free ambient intelligence that is just there when you need it.
Let's help you visualize the hardware. The schematics show an oblate sphere, about 65 millimeters in diameter.
So roughly the size of a golf ball.
Yeah, a golf ball. It weighs less than 35 grams. And thankfully, instead of exposed propeller blades zooming around your living room, it uses 4 heavily shrouded microrotors.
Which is crucial.
It protects your fingers if you grab it out of the air, and it significantly dampens the acoustic whine that you usually get with microdrones.
But the physical constraints of building something that small are staggering. Because it is so tiny, and because it has to generate enough lift to fly, weight is the ultimate enemy of the engineering team.
Every gram counts.
Every fraction of a gram. And that brings us to the biggest engineering constraint they face across all these documents, which is the power supply.
The battery.
A device this small and light can only carry a 250 milliamp hour lithium polymer battery.
That is tiny.
To put that in perspective, that incredibly small capacity gives it a maximum flight time of about 8 to 18 minutes, depending on how aggressively the motors are working and how much data it's processing.
Okay, let's unpack this. Because, wait, I'm looking at these battery specs, and an 18-minute maximum flight time on a consumer tech device seems like a total non-starter.
It sounds terrible, yeah.
How is that not a fatal flaw? Nobody is going to want to buy an always-on AI companion that literally dies and falls out of the air before you even finish cooking breakfast.
On paper, it absolutely looks like a fatal flaw, but the behavioral solution they engineered to get around the battery physics is actually brilliant.
What do they call it?
The firmware documentation refers to a state called perch and listen mode.
Perch and listen.
Right. The Quicknitch isn't actually meant to fly continuously like a traditional photography drone.
Oh, I see.
It flies to you, and then it lands, or perches, on your desk, on the kitchen counter, or even directly on your shoulder. The moment it lands, it completely shuts off its flight motors. but the microphone array and the edge AI stay active.
Ah, so it becomes a stationary smart speaker when it doesn't strictly need to be moving.
Precisely. And by cutting the power to the motors, they stretch that tiny battery from a few minutes of flight time to about 4 to 6 hours of active listening time.
Wow. And looking at the mass production playbook, when it does finally need a charge, the solution is pulled straight from the wireless audio industry.
Yes, the AirPods comparison comes back here.
It comes with a pocket-sized magnetic charging case. The case holds a much larger battery that provides 4 to 5 full charges on the go.
You just drop the Quicknitch into the case?
It snaps into place magnetically, charges up via these tiny pogo pin contacts, and it's ready to fly again in minutes.
It is extreme miniaturization at its absolute finest. And if we look under the hood at the actual component layout, the hardware density is mind-boggling.
Let's talk about the board.
The main brain of the device lives on a circular 4-layer board that is only 28 millimeters across. On that tiny disk, they have packed an ESP32S3 microcontroller, 8 dual H-bridge motor drivers, and an entire complex array of environmental sensors.
I noticed those motor drivers in the schematics, and the flight mechanics here are wild.
Yeah, it's not a standard quadcopter.
Not at all. Most consumer drones use a standard setup with 4 motors, but the Quicknitch uses 8 coreless brushed DC motors.
8 of them.
It has a coaxial dual rotor setup, meaning rotors stacked directly on top of each other, dedicated entirely to vertical thrust. Then, it uses 4 separate lateral tilt motors, specifically for moving forward, backward, left, and right.
And that solves a major camera issue.
Exactly. Instead of pitching its entire body to move forward like a normal drone, which would make the camera footage nauseating, it stays perfectly level and uses the lateral motors to glide around.
And controlling 8 independent motors dynamically requires serious precision, especially because this device is designed to fly indoors, completely without GPS.
Because GPS is useless inside.
Right, the signals bounce around inside houses, making them useless for micronavigation. So to keep it from bumping into walls, it fuses data from a sophisticated sensor suite,
It has a downward-facing optical flow sensor.
which essentially watches the pattern of the floor to calculate its speed. It also has a barometer to hold a perfectly steady altitude. And it's running a 6-axis inertial measurement unit.
And that IMU isn't just passively collecting data. The firmware shows it's processing a Magic filter at 500 hertz.
500 times a second, exactly. To visualize what that means, imagine trying to balance a heavy broomstick on the palm of your hand while sprinting through an obstacle course.
That's a great analogy.
That is the level of constant adjustment required to keep a 35-gram sphere stable in the air. The algorithm is doing the 3D spatial math to recalculate its balance, orientation, and motor output 500 times every single second.
And to stop it from hitting you in the face, the schematics show 4 infrared time-of-flight sensors looking outward in all directions.
And the TOF sensors.
Yeah, these sensors essentially shoot out invisible light to measure distance, creating a 60-centimeter digital protection bubble around the device.
Like an invisible force field.
If a wall, a pet, or a person gets inside that bubble, the Quicknitch automatically fires its lateral motors and pushes itself away. But reading through all these high-end specs, the time-of-flight sensors, the 8 motors, the 500 hertz processing, you would think this thing would cost $1,000.
Easily.
Yet the mass production playbook targets a bill of materials at just $30.
Which is incredibly disruptive.
By tapping directly into the existing micro FPV drone supply chain in Shenzhen, they are getting these components at scale for pennies. They plan to retail this device for somewhere between $129 and $149.
At that price point, the hardware is almost a loss leader, or at least highly commoditized, because the hardware is really just the physical vessel.
Right.
The true magic and the core value of the product happens in the AI architecture. The development blueprints describe their philosophy as thin edge, rich cloud.
So the Quicknitch isn't trying to be a flying supercomputer.
Not at all. The edge processing, the computing done locally on the physical drone, is handled by a highly specialized chip called a HiMax WEI plus AI accelerator.
Which is tiny.
Practically microscopic and incredibly efficient. It runs on less than 5 milliwatts of power. Its only job is to run a heavily compressed INT8 neural network to handle 3 things.
The wake word, right?
Yes, the wake word, which is, hey, Nitch. Second, recognizing basic visual gestures like a thumbs up or a wave. And third, tracking the user's location so it knows where to look.
It does the absolute bare minimum to know when you need it and where you are in the room.
Exactly.
Here's where it gets really interesting. I was looking at the cloud architecture blueprints,
Yeah.
and the pipeline they've built for when you actually speak to it is wild.
It's a massive handoff.
Once that edge chip hears the wake word, the device wakes up its main Wi-Fi radio and immediately offloads all the heavy lifting to the cloud. The audio from your voice is compressed into a tiny 32 kilobit per second Opus stream.
And it fires that stream over WebSockets to a backend built entirely on Amazon Web Services.
The pipeline in the cloud is a masterclass in modern AI orchestration. It doesn't just send your audio to a chatbot. First, the audio hits OpenAI's Whisper model,
which instantly transcribes your spoken words into text with incredible accuracy. But then it routes that text through a DynamoDB memory service before it ever generates a response.
and that memory service is using RAG, right?
Right.
Retrieval Augmented Generation.
Exactly. RA is the secret sauce here. In real time, the system searches a vector database of your past conversations, your habits, and your preferences.
It pulls up that relevant context and injects it into the prompt.
So when the AI formulates its response, it actually remembers that you prefer your coffee black or that you were stressed about a meeting last Tuesday. It feeds all of that context, plus your transcribed voice, into a massive large language model like GPT-4o.
GPT-4o generates the conversational text response, and then a final service, 11 Labs, converts that text back into a highly emotive, natural-sounding human voice.
And that audio file is streamed straight back down to the tiny speaker on the Quicknitch.
And we have to highlight the latency goal for that entire round trip. From the moment you stop speaking, up to AWS, through whispered transcription, through the DynamoDB memory retrieval, into GPT-4o for response generation, over to 11 Labs for voice synthesis, and back down to the physical device.
The engineering goal is under 1.2 seconds.
That is absurdly fast for that many hops.
It has to be. In human psychology, conversational latency is everything.
Right.
If it takes 3 seconds to reply, it feels like you are issuing a command to a smart speaker.
Like talking to a walkie-talkie.
Exactly. But if it takes 1.2 seconds, it perfectly mimics the natural cadence of human conversation. That speed is what makes the interaction feel like you were talking to a living companion rather than a machine.
But of course, that brings us to the elephant in the room. No matter how conversational it is, you are inviting an autonomous flying camera with an always-on microphone in your bedroom, your kitchen, your private spaces.
Yeah.
A lot of people are going to read these specs and find the entire concept inherently invasive. Privacy and safety are massive hurdles for consumer adoption.
They absolutely are, and the engineering documents show the company is acutely aware of that friction. They are implementing a privacy-by-design approach at the foundational hardware level.
What does that look like in practice?
For instance, there is a hardwired red LED indicator on the drone that physically illuminates whenever the camera sensor receives power.
Hardwired is the keyword there.
Because it is a hardwired circuit, it cannot be bypassed by a software hack or a malicious third-party app. If the camera has power, the light is on, period.
The source documents also outline a strict privacy protocol called No Stranger Face Storage. The Edge AI accelerator is trained to recognize the primary owner's face for tracking purposes, but any unfamiliar faces it detects in the background are blurred by default.
Right at the edge.
Right, before any visual data is ever processed or analyzed. They're building in guardrails to ensure this doesn't accidentally become a flying surveillance nightmare when you have house guests over.
What's fascinating here is how the physical design of the device actually bypasses major regulatory hurdles that usually plague the drone industry.
The weight limits.
Because the Quicknitch weighs well under 250 grams, coming in at 35 grams, it falls into a massive regulatory loophole. In the United States, it is largely exempt from Federal Aviation Administration drone registration requirements for recreational indoor use.
And the same exemption applies under EASA regulations in the European Union.
Right.
And to make sure users don't accidentally run afoul of the outdoor aviation rules, the device utilizes strict software geofencing. It is programmed to physically prevent itself from flying outdoors above certain heights, tethering it strictly to that unregulated indoor consumer space.
Keeping it in the house.
But zooming out from local consumer laws, the source documents also include a very intense geopolitical risk assessment. The question they are trying to answer is, could a mass-market micro-drone like this be weaponized?
It is a critical question for any technology that flies autonomously. And the policy documents provide a very impartial, objective analysis of the dual-use technology risks.
Right.
On one hand, the physical engineering constraints of the Quicknitch heavily limit its use as a traditional kinetic weapon. The payload capacity is less than 20 grams.
That is far too small to carry meaningful explosives or dangerous materials.
Exactly. Additionally, the wireless range of its radios is restricted to less than 2 kilometers, meaning it cannot be used for remote long-distance attacks by bad actors.
So physically, it's too small to carry anything dangerous, and its signal can't reach far enough to be a remote threat. But looking at the regulatory assessments, the concern isn't really about the physical plastic and motors, is it?
No, the hardware itself isn't the primary concern. If we connect this to the bigger picture, the underlying systems technology is highly coveted by militaries worldwide.
The software and algorithms.
Yes. The Quicknitch relies on incredibly advanced miniaturized sensor fusion, getting optical flows, barometers, and flight controllers to work in perfect harmony on a tiny, cheap board. Furthermore, the potential for autonomous swarm coordination,
Having multiple intelligent micro-drones communicate.
share data, and move together without human input. That is a major focus of modern defense research.
Which means the company is navigating a total minefield of international export controls just to sell consumer gadgets.
Exactly. The physical drone might easily clear customs as a harmless consumer electronic. However, the autonomous AI flight algorithms, the edge processing neural networks, and the mass production supply chain playbooks capable of producing these autonomous systems at scale, those are incredibly sensitive geopolitical assets.
The intelligence inside the device faces far more international scrutiny than the device itself.
The policy risk assessments highlight how deeply entangled even a benign consumer product is within global security frameworks today.
It really shows how complex launching a piece of hardware is in the current global climate. And speaking of global strategy, the company is taking a highly tailored approach to the massive Chinese market.
They aren't just shipping the exact same product overseas.
They are completely adapting the device, starting with the branding. In China, the device will be sold under the name Jinling Su, which roughly translates to golden feather speed.
And the marketing strategy there is distinctly cultural. Rather than positioning it simply as a smart home gadget or a floating Alexa, it is being marketed as a Lingchong.
Which translates in English to a spirit familiar.
Right. This taps directly into deep cultural themes and wildly popular fantasy literature in the region, framing the AI not as a utilitarian tool, but as a magical living companion that shares your space.
But the localization changes aren't just cosmetic marketing. The entire back-end technology stack has to pivot drastically to comply with local data and internet regulations.
The cloud architecture blueprints show they're completely swapping out Amazon Web Services for Alibaba Cloud.
OpenAI's GPT-4o is stripped out and replaced by locally compliant large language models, like Alibaba's Quinn or Baidu's ErnieBot.
And perhaps the smartest strategic move for that specific market, instead of forcing users to download a standalone proprietary app to control the drone, the entire device ecosystem is integrated directly into WeChat.
That's huge.
From pairing the device to managing its memory settings to issuing flight commands, it all happens inside WeChat. They are placing the hardware seamlessly inside the digital ecosystem where the users are already spending their time.
So what does this all mean? When you step back and look at the embedded C++ code, the Shenzhen supply chain documents, the massive AWS pipelines, the Quicknitch isn't just a cool toy that follows you around the kitchen.
No.
It really represents the transition from the smartphone era into the ambient intelligence era. It is the first major step toward computing that lives alongside you in the physical world, rather than requiring you to constantly dive into a digital screen.
The sheer engineering required to make that interaction feel seamless is truly monumental. You have 1000 hertz PID control loops constantly micro-adjusting 8 tiny motors just to keep it hovering silently in the air.
It's incredible.
You have highly compressed audio streams flying to the cloud, querying a database of your personal memories, generating an empathetic response, and beaming back down in under 1.2 seconds. It is a massive orchestra of bleeding-edge hardware and software harmonizing perfectly to create the illusion of a simple living companion.
It is a massive leap forward for consumer tech. It completely changes how we will interface with information in our homes.
It does. But looking at how deeply this technology integrates into our lives, it raises a fascinating and somewhat haunting implication.
What's that?
We've spent this time talking about how the DynamoDB memory service meticulously catalogs your habits, your voice, and your daily micro-interactions to make the AI more helpful today.
Right, to be a better assistant.
But fast forward a few decades. If these ambient companions constantly record our personalities, storing years of our conversational nuances in the cloud, what happens when we pass away?
Wow.
We might think we are just building flying smart assistants, but with this level of perpetual memory retrieval, we might actually be laying the groundwork for the first generation of autonomous, interactive digital ghosts. Something to think about next time you ask your device for the weather.